This is Engage New York, Module 4, Lesson 3. This is our problem set / concept development. So we're doing two at once right now. So a baker, here's our problem. We're starting with this problem, 4 divide 3, and then they're giving you a word problem to work off of. So a baker poured 4 kilograms of oats equally into 3 bags. What is the weight of each bag of oats? So we have, here's our 4 holes of oats, and then we're going to divide it equally into thirds. So when you share equally, it means taking what you have and dividing it into equal groups. The total is 4 kilograms of oats being divided into 3 bags. So the division sentence is 4 divided by 3. The whole is 4 and the divisor is 3. So 4 divide 3. So let's represent the kilograms with squares like we did yesterday, and the squares are easier to cut into equal shares than circles. So right here, we have our 4 kilograms. So every bag will get a whole kilogram of oats, and then we will split the last kilogram equally into thirds. Okay, so here we go. So as you can see, I have 4 holes, right? And now we're going to divide into 3 bags. So here's 1 bag, 2 bags, 3 bags. And now we have one bag left over, right? So how can I, because remember, we're splitting this equally, how can I make sure that each bag gets the same amount? Well, I can cut this bag into thirds, right? So here's 1, 2, 3, and here's a third, here's a third, and here's a third. So if we passed this out, so a baker poured 4 kilograms of oats equally into 3 bags. What is the weight? 1 1/3 kilograms, right? So each bag gets a whole kilogram and 1/3 of another. So another way of attempting that problem, because remember, we can do it 2 different ways to represent your thinking and how your brain divides things up. So I can cut all of these 4 bags. I can cut these bags of oats up into thirds and then split them into 3 bags. So I can cut them into thirds. Each bag will get 4 thirds. So let's see. Here are our 4 kilograms of oats. And then if we break it into thirds, so here's a third, here's a third, here's a third, all the way through. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many thirds do we have? Well, that made 12 thirds, right? All right, think about this for 1 second. So, what is the weight of each bag of oats? So now, what are you going to do? What do you do next? Think about it for 1 second and write it down. Okay, so we have 1, 2, okay, let's go back. So we have we divided this up and we have 1 1/3 kilograms. So we passed it out and then we broke the leftover into thirds and we got 1 1/3 kilogram, 1 1/3 kilograms of oats. Now we could also, another way of doing it is take all 4 kilograms of oats and divide them equally into thirds. So 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, 1/3, and gives us 12 thirds. So if I take 1/3 from each one, I end up with 4 thirds. Well, 4 thirds is what we started with, and 4 thirds is 1 1/3 kilograms as well. So 12 thirds, and that becomes 4 equal groups right there. So we could have 12 thirds divide by 3 equals 4 thirds. That would be the unit form. All right. Now 4 thirds as a mixed number, 4 thirds as a mixed number is 1 1/3. Now, how about if we use the division algorithm? How about if we just switch over and we switch over to division algorithm? So 3 divide 4 is 1. So 1 1/3, right? And then how do we check that answer? So remember, we know how to check answers by going 3 times 1 1/3. That's going to give us, well, it's 1 1/3 plus 1 1/3 plus 1 1/3, right? Which is, if we pull out the whole numbers, that's 3 plus 3 over 3, which takes us back to 4. So, long story short, there are several ways to solve a division problem like this. So 4 divide 3, here is one way to do it. 4 divided by 3, here's another way of doing it. Then going to the division algorithm is another way of doing it. So one group of 3. Here's 3, and 3 over 3 takes us back to 4. That's what we did. Now, let's move on to problem 2. Now, as you can see, I took up a lot of room here because I wanted to show you the different ways to actually solve. So, if a baker doubles the number of kilograms of oats to be poured equally into 3 bags, what is the weight of each bag of oats? So, let's see. So 4 doubled is what? 4 doubled is what? Well, 4 doubled is 8. And we know 4 times 2 is 8. The baker now has 8 kilograms of oats to pour into 3 bags again. So, what is the whole number? The whole number is 8. What is the divisor? The divisor is 3. So, 8 divide 3. Now, how are you going to solve this? So, which method do you like? Are you going to break it up like this, or are you going to break it up like this? So, compare the expression with the one we just completed. We have 8 divide 3, and we were at 4 divide 3. So the whole is twice as much as the problem before. The number of shares is the same though. So why don't you make a prediction? What do you think? If 4 divide 3 was 1 1/3 kilograms, what do you think 8 divide 3 is going to be? So let's go ahead. Let's draw it out. Here's 1, 2, 3, 4, 5, 6, 7, 8. So we have 8, right? So into 3 bags. So probably the easiest way, we could go 1, 2, 3, 1, 2, 3. Right? Here are 3 bags. So we just passed it out or distributed it, right? Then we could take our last 2 and break that into thirds. So we have a third here and a third here. So instead of having 1 1/3 kilograms, we're now going to have 2 2/3 kilograms of oats. Another way of doing it? Yes, there are other ways of doing it. You could break it all up into thirds, and that would be 8 times 3. That would be 24 thirds, right? Another way to do it? So here is one way of doing it. How about if we use division algorithm? 3 divide 8. 2 2/3. So how do we check it? 3 times 2 2/3 is going to give us, well, 2 2/3 3 times 2 2/3 plus 2 2/3 plus 2 2/3. We pull out our wholes, we're going to have 6. 1, 1, 2, 3, 4, 5, 6. We're going to have 6 thirds, which is 6 plus 2 takes us back to 8. So our last problem, problem 3, I want you to take a look at that. Problem 3. Now, if the baker doubles the number of oats again and they are poured equally into 3 bags, what is the weight of each bag of oats? So in problem 1, it was 4 divide 3. In problem 2 is 8 divide 3. So in problem 3, we're going to double this again. So now it's 16 divide by 3. So what is your estimation? What do you think of what we're going to do next? So what's your estimation? If this was 1 1/3, this was 2 2/3. I wonder what it's going to be for this one. So I want you to go ahead and try to solve this the same way we just solved it. I want you to solve this 2 ways. I want you to draw it out, and I want you to use division algorithm. So try it and come on back. Okay, so I drew it out this way. I drew out my 16. I divided them up. I passed them out, and I ended up with 5 1/3 kilograms. Then I came over here and I used the division standard form, and got 5 1/3. Then I came over here and checked 3 times 5 1/3, because remember, you multiply this way here in order to check. 5 1/3 plus 5 1/3 plus 5 1/3 is 16. So how many 1/3s do we have? So if I had to break this up, 16, if I took all 16 of these boxes and I divided it and I broke them up into thirds, I'd be multiplying by 3. It'd end up with 48 thirds. Do you really want to draw that out? No. It's easier to use standard algorithm, right? All right, so that's our big idea for today. So what you're going to do is take your problem set, and you're going to show me unit form. So 5 divided 4 is 20/4. Divide by 4 equals 5/4. I want you to show me the improper fraction. I want you to show me the mixed number, and I want you to show me the standard algorithm, and then check it. So there are only 4 problems like this. And part of it's even filled in for you. Then you have a principal evenly distributes 6 reams of paper. A ream of paper is that package of paper. Reams of copy paper to 8 fifth grade teachers. How many reams of paper does each fifth grade teacher receive? Explain how you know using pictures, words, or numbers. If there were twice as many reams of paper and half as many teachers, how would the amount of amount each teacher received change. Explain how you know. So then we have a caterer has prepared 16 trays of hot food for an event. The trays are placed in warming boxes for delivery. Each box can hold 5 trays of food. How many warming boxes are necessary for delivery if the caterer wants to use as few boxes as possible? Explain how you know. If the caterer fills a box completely before filling the next box, what fraction of the last box will be empty? Not how much will be in it, what fraction will be empty. Then that'll do it. That will do it for problem set lesson 3. All right. So your goal is to try to attempt this page, filling it in, follow. If you have to draw a picture to figure out how many halves that's going to be, do it. If you need to break this down to figure out what this is going to be, break it down. Draw a picture. RDW, read, draw, write. Come back to check your work once you have completed the problem set.